Have you ever faced a frustrating issue while coding, only to find that your decompression routine fails unexpectedly? If that's you, then you're in the right place. Today, we're diving into a common problem with ZLib decompression on large byte arrays. I understand how annoying it can be when your code doesn't work as expected, especially after you've put in so much effort. You're not alone in this. Many developers encounter similar issues with ZLib compression and decompression. Here's the specific situation we're looking at. One user recently reported that decompressing a ZLib compressed byte array fails when the source array is at least 32,752 bytes long. They provided a code snippet that reproduces the problem. Sound familiar? Let's dig into this together and find a solution. So, what could be causing this issue? It could be a bug in the ZLib library, or there might be an error in the compression and decompression routines. We'll break it down step by step to help you figure out what's going on. And don't go anywhere. I've got a crucial tip at the end that will help you avoid similar issues in the future. To address the decompression issue, the user should first check the buffer size used during decompression. The current buffer size is set to a maximum of 1,024 bytes, or 1/10 of the data length. This may not be sufficient for larger data sizes. Next, the user should modify the decompression method to handle larger byte arrays more effectively. This can be done by adjusting the buffer size dynamically based on the input data size. Additionally, the user should ensure that the input data is valid and properly formatted before attempting to decompress it. This includes checking for any potential data corruption. Finally, the user can run tests with various data sizes to confirm that the changes have resolved the decompression issue. This will help identify if the problem persists with larger byte arrays. Did you know? The ZLib library is widely used in many applications, including PNG image compression and data transmission. It's a powerful tool, but like any tool, it can have its quirks. Now let's look at the answers provided by other users. An alternative solution was provided by another user. They identified that the original compress method had issues. Their revised method uses a byte array output stream to collect the compressed data. It processes the input in chunks, ensuring that all data is properly written to the output stream. That's all for that response. Let's see what someone else had to say. A user identified a logic error in the compress and decompress methods. They found that when compressing a 32,752 byte buffer, the deflator returns a size of 32,767 bytes, which is not enough to hold all the compressed data. To fix this, they suggest increasing the buffer size to 4 times the maximum short value. The user also points out that if the buffer is too small, the inflator may return 0, indicating more data is needed, leading to an endless loop. They recommend processing data in chunks to avoid this issue. Here's the crucial tip I promised. Always validate your input data and handle exceptions gracefully. This practice can save you a lot of headaches down the road. And there you have it. With these troubleshooting steps, you should be able to resolve the decompression issue. Remember, validating your data and understanding your tools is key. If you found this helpful, hit the subscribe button for more tips and don't miss our bonus tip on optimizing your compression routines.